Hi everybody, this is Professor Kleiman and Alex Rack, and we are going to present today we start our labs related to DNA recombinant techniques. The first one we will use is digestion of DNA with restriction enzymes. Remember, restriction enzymes are enzymes, proteins, that have been purified from bacteria, and they recognize certain sequences. The reason that we have restriction enzymes is because the bacteria protect themselves from the invasion of stranger or invasive DNAs like a virus, and with the restriction enzyme they can digest it. So they will recognize sequences between 4 nucleotides to 6, and what they do is to cleave the phosphodiester bond. So there are different restriction enzymes, and
Right, so today, in today's experiment, you would be partnering up into groups, and you would be working with one of two plasmids. Plasmid is the genomic sequence from bacteria. It's usually, it's a circularized loop. And the two plasmids used in this experiment are PBR322 and PUC19, PUC19. But because I'm only going to be doing one, I just listed plasmid here. Each of those two plasmids can be digested using the two restriction enzymes PST1 and BAMH1. And both of these enzymes will recognize different genomic sequences, and they will cut that specific sequence. So in our plasmid, we know that there is one cut site for PST1 and one cut site for BAMH1. So if we have our plasmid like that, we have one cut site where PST1 will recognize, and these are just general locations, they are likely not accurate, PST1 and BAMH1. So if we were just to analyze the genomic DNA by itself, just the plasmid, it would be circularized, and it wouldn't visualize well in a gel. If we treat this plasmid
remember that the undigested will be super coiled, and it will run in a very different way than after digestion.
If we treat it with PST1 or BAMH1, what we would expect to see is a linearized product, where that plasmid has been cut in one of these two locations, and we now have from a continuous loop to almost like a string, one line. If we were to treat this plasmid with both of these enzymes at the same time, we would get a cut here and a cut here. And the result would be two separate linearized pieces of DNA. So the purpose of this experiment is we're going to be looking at two different plasmids, again PBR322 and PUC19, and we're going to be doing single digests with just PST1 and just BAMH1, and we'll be doing a double digest with BAMH1 and PST1 all together. So the different components of these reactions obviously are the plasmid, whichever one you're using, your enzymes, 10x BSA. BSA is bovine serum albumin. It's a protein that helps stabilize everything. DNA can be kind of sticky when it comes to plastic. So if we add our BSA to the reaction, this helps make sure that none of the DNA sticks to the sides of the tubes or the pipettes we're using. We have 10x buffer 3. Basically, the companies that manufacture these enzymes and produce them have different buffers that these enzymes will enzymatically work under, different pH and ionic concentrations. And then we also have deionized water, because each of these reactions has to be a final volume of 25 microliters.
So when you know the final volume of 25 microliters, you know that if we discussed it before, if something is 10x, it's going to be 10 times more concentrated that you need, and you need to make it 1x, so it's 2.5. So we know the final volume will be 25 microliters. So remember that when you see the 10x.
Okay, so rather than go through all of these reactions for you, I'm just going to choose one of them. So I'm going to be doing, let's do this one here. This will be a single digest using the restriction enzyme PST1.